Okay, we are back. Sorry about that. I'm a little long-winded than I anticipated. My phone didn't have the data to keep recording. Okay, so last we were at the stretch reflex, which was a somatic reflex, and I was talking about the muscle, specifically the quadriceps femoris, in the knee jerk reflex, and I was saying that when there is a sudden stretch, in that case when the doctor hits your knee with the mallet, when there is a sudden stretch, your muscle fights back in a way by contracting to prevent the stretch from being too excessive. And there was one more figure that I wanted to show you from Saladin. It's the same reflex, but a little bit more detailed. I wanted to point out an important aspect of it. So here's the figure from Saladin, and it's showing again the same exact reflex, same reflex arc as I mentioned before, but this one is a little more detailed. It shows you the efferent nerve coming down, and it's exciting the quadriceps femoris muscle, which is in the extensor, so it's going to cause your leg to kick out, by giving it an EPSP, which is an excitatory postsynaptic potential, and that depolarizes the membrane. It makes it more positive, and then that causes the muscle to contract. It excites it. But what the other figure didn't show was that at the exact same time, this reflex arc, there is an efferent neuron going to the hamstring group, which is an antagonist to the quadriceps group. They are knee flexors, which would do the opposite action. And what happens is the reflex, this efferent nerve, it goes down and it transmits an IPSP to the hamstrings. So instead of exciting them, IPSP stands for inhibitory postsynaptic potential. Instead of exciting them, it actually inhibits them. It prevents them from contracting by hyperpolarizing their membrane, so it causes it to become more negative. Because if this reflex is going on, you want the quadriceps to contract, you don't want anything to prevent that from happening. You know, this reflex, if you're going to have your knee kick out, your leg kick out, you don't want another contraction holding it back. So you want to prevent the hamstrings from contracting and allow the quadriceps to contract instead. And so at the same time, you have this EPSP going to the quadriceps, exciting them, causing them to contract, causing the leg to kick out. The same reflex arc is inhibiting the hamstrings muscles on the back of the leg to prevent knee flexion at that same moment. So I think that's very interesting, the EPSP versus IPSP. That's a bit of another blast from the past, from older chapters on action potentials and such. And the last two somatic reflexes I wanted to, well, three, I guess it is three that I want to talk to you about. The first one is a little bit different from the stretch reflex. It's proprioception. So you have these muscle spindles, where you have nerve fibers intertwined with muscle fibers. And again, this is outside of your conscious awareness, even if it is a somatic reflex. You are aware and yet not having to think all the time about where your body is in space. So it's like your brain and your spine, they're keeping tabs on the contraction of all the skeletal muscles throughout your body. So even if I don't really think about it, I know that right now I am standing up. And that's important because that helps me keep my balance. That helps me be aware of myself in space, which could be a survival reflex too. I want to know where I am at all times. So that's an interesting one, and it's almost just an aside, really. For what I'm about to talk about next, it's a little more related to the stretch reflex. And this is the flexor reflex, or the withdrawal reflex, and this is pretty familiar too. This is the reflex that, you know, when you touch your hand to a hot stove, you jerk your hand back real quick. You know, your arm flexes because you're trying to prevent further injury. Even before you realize, you know, the pain is really there, you're jerking your hand back because you don't want to get burned any further than you are. So the example I'm going to use is stepping on a Lego, which is pretty universal and I think pretty unpleasant as well. The book gives, I think, stepping on a glass bottle, but we'll keep it at a Lego. So let's say, you know, you're walking, you step on this Lego. There are pain receptors in your foot on the skin, and they send a signal through the afferent nerve up to your spinal cord. So this is a spinal reflex. Spinal cord makes a decision, sends motor efferent neuron signal back, and your leg flexes. You want to get it out of there. You want to get it out of the way. You want to prevent further injury. And so what happens with this flexor reflex, to make the whole limb flex, you want to give an excitatory postsynaptic potential to, in this case, the hamstrings, the knee flexors, and you want to give an IPSP, an inhibitory postsynaptic potential, to the quadriceps, the knee extensors, because you don't want the leg to stick out farther if you're stepping on something that's hurting you. You want it to be retracted, to pull back. But think for a second, if that's all you did, if all you did was just pull the one leg up, well then you'd probably fall right over. So at the same time, there is not just the flexor reflex, but what is called the crossed extension reflex. And the crossed extension reflex makes sure that while you're pulling up the one leg, the other leg, the contralateral leg, so opposite side, becomes extended, because you want to keep that leg as the one that you're standing on, the one that you're balancing on. You don't want to fall over. There could be more Legos on the floor. So while this leg, the flexed leg, is having an EPSP here and an IPSP here to keep it flexed, this leg is the opposite. You're having an IPSP for the knee flexors, but an EPSP to excite the knee extensors. You want this leg to stand straight and tall and support your weight. And at the same time, this reflex, cross extension reflex, tightens your abdominal muscles and you shift your weight over onto the other leg. And again, it's all to protect this leg that has been injured, and you want to prevent any further injury to it. So, that's somatic reflexes, or all the ones that I'm going to talk about. I hope you'll look up more. And I think the EPSP versus IPSP is a nice review, not only of the nervous system, but also of action potentials in general. So